Okay, let's solve another exercise. In this one, we're given this function here, e to the absolute value of x. Or you might as well write this as the exponential of x, of the absolute value of x, depending on your taste and your notational style in your lectures. So the question for this exercise is this differentiable? So can you find a derivative at every point? This is what this is asking. And well, let's see. To solve this exercise, we basically need to remember the chain rule. So let me remind you of the chain rule. This says something about the composition of functions and about it says something about the derivative of composition of functions. So if you have a function f and you compose it with a function g, so f and then g, and you want to have the derivative of this composed function at a point x, then the chain rule, I'm sure you remember, says that this derivative is given by g at the point f of x, and you take the derivative of this and you multiply this by the derivative of f at the point x. So this was the chain rule. And now let's see how the chain rule solves our exercise. Well, you can view this this e to the absolute value of x, or this one, as a composition of two functions. Namely, your f is now this one, the absolute value function. So that's a function that maps every x to its absolute value, and your g is the exponential function. And then g after f is precisely what we started with. So g after f is the exponential of the absolute value of x. And now if we want to look at the derivative of this, so the derivative of the exponential of the absolute value, this is what we want to calculate at a point x. Then according to the chain rule, what we have to do is well, just look at this formula here. We have to look at the derivative of the exponential function, but the exponential function has the property that it is its own derivative. So we have the exponential function evaluated at the point absolute value of x, and we multiply this by the derivative of our function f, which is in this case the absolute value. So we would like to write something like that, but now here we run into a problem, because as you surely remember, this function, the absolute value of x, does not have a derivative. So maybe a quick drawing. The absolute value function looks like this. And at this point here, at 0, there is the problem. there is no derivative because you have this this kink here, and so here we have no derivative. So what this means for our example is that we cannot write the derivative of this function e to the absolute value of x, and this means that the answer to our question, the answer to this exercise, is no by what we have just seen. So thank you for watching. See you next time.